I'm going to spend the next 20 minutes just talking about our analytical strategies and how you can understand your molecule, get to know it, and how that can kind of future-proof your analytical programs and your manufacturing for long term. So I'm representing FUJIFILM Biotechnologies. We're a world-leading CDMO with 25 years of experience. We've touched 300 molecules over our time with three core technologies in microbial, mammalian, and now viral and gene therapy. And I'm going to use that kind of design space of expertise and describe how we approach our analytical programs. So we can take your clinical journey through preclinical all the way through commercial production, and I'm going to talk about how the analytics factor into that over the time frame of this journey. So to begin with, I want to start talking about what a protein is, and I want to introduce the concept that proteins have personalities. They are unique molecules. Their structure influences how they behave. And it's really critical to work on understanding that personality and let your analytical methods guide that understanding. So some steps that we take towards evaluating their personalities is elucidating the amino acid sequence, using molecular informatics and modeling to get to know the molecule, and characterizing the three-dimensional structure. That allows us to then go in and look at the degree of the post-translational modifications, which I'll touch on coming up. And so that knowledge really ensures that you're consistently developing methods. It's safeguarding these methods for the long term. And one important aspect, by knowing what your molecule is going to behave as, it recognizes when you might be stepping out of your design space or your knowledge process space. And that kind of future-proofs your program for the long term. So a critical part of this is understanding the critical quality attributes of a protein. We've got three examples here: E. coli expressed proteins, a monoclonal antibody, or a mammalian expressed protein, and a little small to see. But there's a whole host of different types of post-translational modifications, and depending on the application, some may be critical attributes and other times they're not. So we need to be factoring those in as we approach the clinical development life cycle. And so when we start to look and talk to our clients about programs that are coming in, we want to really understand what's their development driver. And we kind of break it into three categories, really kind of balancing speed versus science. Everybody wants speed, everybody's asking to make it as fast as we can, but sometimes science is better and science is slow. So what we really want to try to do is to create that balance between speed and science. So what is balance to us as we think about it from an analytical development program? It's being driven by understanding the product's quality attributes that I touched on. It's knowing that design space to rapidly deliver early phase programs. But what we also want to do is have a line of sight from that initial development through GMP manufacturing. And that's going to ensure consistent